Hey folks, welcome back to EarthSky, and we've got really beautiful, beautiful dream for you today in the truest sense of the word or the world. So anyway, welcome, thank you, and remember we're here every weekday at this time from here on out. And today we're going to be talking about science and art and where they meet, especially where they meet at the Space Telescope Science Institute, which is where my guest today works. And her name is Alyssa Pagan. Hi, Alyssa. Welcome to the show.
Thank you for having me.
We had a Oh, thank you so much for being here. Let me tell you, folks, about Alyssa for just a sec. She is one of the people, a science visuals developer at the Institute. And these are the folks who manage, the Science Institute manages those two telescopes, the Hubble and the James Webb. And Alyssa is both an astronomer, a degreed astronomer, and a degreed illustration artist. And she's merged these two together. And her job is turning the raw data into the beautiful images, just like this one. Let's take a look at her latest effort. I am absolutely gobsmacked when I saw this. What are we looking at, Alyssa? Tell us all about this.
Yes. So this is the Carina Nebula. Well, technically, it's actually a small part of the Carina Nebula complex, actually called NGC 3324, which is like a very big cavity star-forming region. This is just like a small edge of it. So this is a visualization of this region. So there's a larger media team that I'm a part of that made this wonderful visualization. So placing the stars in 3D space and then cutting up these layers that make up the 2D image so that we can understand this object and what it could be in 3D space. There's a little bit of, speculation that has to be done, but it is based off of scientific information and papers in order us to get the best sort of idea of what it's like.
Well, that's why it's an artwork and why you're involved, right? So where is this in space? If people wanted to go out and sort of try and look in that general area tonight, maybe, where is that?
So it is in the southern hemisphere. So you have to be in the southern hemisphere in order to see it. It's basically in the galaxy's disk. So if you have the galaxy's disk in view, you'll see the larger Carina Nebula. So it's pretty bright and pink, so it can be easy to see in dark skies. You can see it probably naked eye, I would say. And then also, of course, you can take telescope images of it. I haven't seen it with my own eye, unfortunately, but I have seen it with Webb.
Okay. Is this what we would see if we were right there?
So we get this question a lot. And I would say the short answer is no, but there is a reasons for that. One, it's infrared telescope. So since it's infrared, it's light that we cannot see with our eyes. So there has to be some sort of representational, showcasing of the data that we have to do. Secondly, the telescopes are far more sensitive to light than our eyes. So even though it captures this light, it's getting so much more signal because it has the ability to collect light in this huge bucket. Well, our pupils are tiny and we don't have any light integration. So that's why we're seeing things a lot more sensitive and with a lot more color depth. But that doesn't mean that that's not a reality. It's just not what we can see.
That's what's out there, but this is interpreted so that people, just with our limited senses, we can see it in something that we can perhaps recognize. Exactly. Now, Hubble has a different view. It doesn't look into the infrared and that kind of stuff, does it? Is that right?
That is right. Yes. It's mainly the optical, so visible light, and a little bit into the ultraviolet and a little bit into the infrared, but that's not the primary
but not the way that Webb does its work.
Exactly.
Now here, let's take a look at this guy, because this is really the image that caught my attention. We've got something to celebrate. It's Hubble's 35th birthday, if you will. And this was one of the images that was released. Tell us about this, please. It looks to me like a cosmic storm, and it's just throwing galaxies out left and right. It looks like, I don't know what it looks like, but tell us what we're seeing.
Yes, I like this image as well. I like galaxies using Hubble as well. This is NGC 5335. If that means anything, it's just a catalog number. But this in particular is a a bar spiral galaxy, which is actually quite common. Our Milky Way galaxy is also a barred spiral galaxy. So you basically see that extension in the middle near the bulge. And then you have the spiral arms that in this case are a little bit more flocculent. So they're a little bit more fuzzy and fluffy, as we say. So they're not as well defined. But there's still a star forming region that's happening here. And you can see that in the blue. And then you have the bulge in the center, which is more dusty and has older stars. That's why it looks redder. So like you're actually getting information by the colors in this image. And then because it's a little bit more tenuous at the edges, you're seeing like those background galaxies sort of like pop in, doing a photobomb, as if you will.
I will. I love this image. It's really just caught me. Now let's see. What okay, let's go back for just a second. We're gonna take a trip back here for just a second, and we're back at the cosmic curtain, right? That now this is another historically important image, and that's it. This came from the first data that Webb collected for us, right? Is that correct? Tell us what we're looking at here and what your hand in this was.
Yes, that is correct. This is part of the early release observations. So there was like 5 different objects that were taken data for, and this was one of them. This was the cosmic cliffs. And the visualization, or I should say the media team kind of split up what images we're going to process. I got to take this data on, which was insane and amazing. And it's a star forming region. So there's like different objects that kind of correlate with different, space fields. Fluffy. But yes, my explanation of the galaxy. But it was one of the first times we got to see the data and see how amazing it was, see the resolution that it provided. And we were not only like just inspired and like, mind blown, but I think we were relieved because we were telling people about this space telescope, and that's kind of hard to tell the public, like this is even, this is the predecessor to Hubble. It's going to see infrared like you've never seen before. It's kind of hard to say that to people and have them understand. So getting like the clarity of this image and seeing the color separation, we were kind of worried with infrared because it works a little bit differently, that you're not going to see the colors as clearly. It's not going to be as distinct. That was our concern. But clearly that is not the case here. The features are very much showing very vibrantly. So you can see that the dense dust is that redder like light. And then we can see there's this like tenuous or very hot gas that's in blue. And that's in, so you can see sort of the distinction of what's happening there physically.
Okay. And so the difference between the still image that we're looking at here and the video that we were looking at earlier, is that the same data and you just interpret it differently? And is that what happened?
Exactly.
Wow.
So yeah, it's the same data. It's flat. So obviously we do have to kind of think about what it might look like in 3D space because we don't have like a spectroscopic view. But the stars are actually taken from Gaia data and other catalogs to figure out, their actual brightness and distance. So we put that along with the flat image, and that's cut up and sculpted in space.
Okay. Well, here we've got this is another classic. And is this a Hubble or a Webb? Tell me about this guy. What is this? This is the Pillars of Creation, if you don't know the name of this one.
Yes, this is a Webb image as well. Sorry.
Okay.
Yes, this is a Webb image. And you can kind of tell just kind of by the color palette, which is kind of interesting just because we use the same filters from the Carina Nebula. Or cosmic cliffs to the pillars, and it's also a star forming region. So like you have that same sort of like dense dust that's shown in like the orange and red, and then you see like these embedded stars that are kind of making these like little lava pools in like the densest dust. We kind of we have a name for the different pillars in our team. So the dog pillar on the right, or Spectroprotonus. If you watch Harry Potter, we have the Dementor pillar. I won't get into that.
My daughters will be thrilled to hear about the Harry Potter naming. They love that whole entire series. Okay. Anyway, here's a little bit of, please don't let me stop you. I just want a little better view so people can see this. This is an iconic image, and you worked on it. Please continue.
Oh, yes. We had to do it again. Obviously, we've seen it with Hubble, which is a very iconic image. So we had to look at it in
Mhm.
infrared with Webb. And you can see here, there's a stage, there's methods in order to make it a color image. So it doesn't pop out that way of the telescope. It kind of works like our smartphones, even our eyeballs, where it's taking specific wavelength ranges of light. And then you have to assign them color and then combine them together to get that color image. So on the left, what you're seeing is just one filter, so one wavelength
Okay.
range of information, and it's not stretched. And what we mean by that is it's just kind of the raw data, and we have to scale it in a way to see the brightness values. So it's basically like we need to basically apply like a transformation or a brightness curve adjustment, essentially, because that's the way that it comes out, just because of the sensitivity and the high dynamic range of these telescopes. And then so the one in the middle is one of those filters again, but it's stretched, as
Mhm.
we call it. So we can see all that amazing detail that's sort of hidden in the dark end. And then there's a lot of things that happen at this stage. There's some like artifact correction, like things that remain that are introduced by the detector themselves. So that are not like intrinsic to the observation. So we do that at this stage as well. And then we assign one of these filters an appropriate color. And we do this in chromatic ordering, which we can get into. And then you combine all of those together to get your full color image.
Well, I don't think we need to get too technical. We'll leave that bit to you, but I would like to
That's
jump back over here. And while that runs in the background again, ask you a couple of questions. When you were getting your illustration degree, did you ever think you were going to end up working for NASA, Hubble, Webb? Was that on the radar?
That was not on the radar. It's a very serendipitous for me because I went into illustration and got my art degree at Towson University, and I was like, I really
Mhm.
enjoyed that. But it was also a liberal arts college experience, and so I got to take science courses and math. And I'm like, you know what? I like this too, and I've always loved astronomy. And so it's kind of like a separate, journey. At least I thought they were separate until like junior year of my astronomy degree, and I took a observational course, and I was like, oh, this is this. I see the intersection there. Yeah.
So this is it. And you got yourself in there. There are many pathways into space in the space industries. Alyssa, is anything amazing coming up? I mean, I was going to ask you that, and then you guys dropped this video on us.
Right.
So I kind of feel like I got upstaged there, but sincerely thank you for being with us, and thank you for telling us all about these amazing images that we've been enjoying for 35 years now. Um, so with that said, let me remind everybody who's watching to like and subscribe. That really does help us. But also, let me tell you, we are here every weekday at this time, which is 17:15 UTC or whatever time you're watching right now. Please visit us at earthsky.org. We'd love to see you over there too. Have a great day. Remember, guys, it's one Earth, one sky, Earth Sky.